Okay, there is a physics in which we can say branch of science which deals with uh, matter and energy and relationship between them. A relationship between them is called physics. Here, two main basic terms are used. First one is matter. Matter is everything which has mass and occupies space, which has mass and occupies space in the form of volume over there. On the other end, there is the another thing that is called energy, ability of body to do work is called energy measured in joules over there. But here we will have to go first of all the physical quantities according to our basic first topic over there. Physical quantities means all measurable quantities are called measurable quantities are called physical quantities. And for example, length, mass, time, temperature, length, mass, time, temperature, amount of substance, of substance, 1, 2, 3, 4, 5, 6 can be electric current, and 7 can be luminous intensity of light. After that, length is measured in meters, mass is measured in kilograms, time is measured in seconds, temperature is measured in Kelvin, amount of substance is measured in mole, and also in the chemistry is being done over there. Electric current is measured in amperes. Luminous intensity is measured in candela. If I look all of these for over there, then I can say that these are base quantities. These are SI base quantities over there, which are 7 total. And length is measured in meters. And if I take length in meter, then I can say it is the distance which is traveled in some time over there. I can use the prefixes to make very largest quantities, and I can also use the prefixes for very smallest quantities over there. And length is measured with its devices named as meter rule, vernier calipers, and micrometer screw gauge. And for mass, we can use physical balance, or we can use electronic balance over there. And for time, we use stopwatch, which can be digital, which can be analog also, which can be digital or analog over there. And when we go for temperature, it is measured in Kelvin. And for this purpose, we use in thermometer. But thermometer is available for Fahrenheit degree centigrade as clinical thermometer. And as lab thermometer, it is measured in centigrade. And for converting into Kelvin, we add like temperature in Kelvin. I want to find, then I take temperature in degree centigrade plus 273 to get the temperature in Kelvin state over there. Amount of substance is basically related to Avogadro's number, 6.022 multiplied 10 raised to power 23 atoms present in any substance, then it is named as 1 mole substance. That is called N with A, that is Avogadro's number over there. Electric current is measured in ampere by using ammeter, which is connected in series over there. And it is mostly analog, but digital are also available in the market, which mostly electricians use over there to measure current. Amount of intensity is measured as luminous intensity, power per unit area. But you will study in detail in your A levels over there. But till here, I will say it will be power per unit area, like the sun throwing the light over there, and falling per unit area. Watt per meter square can also be taken as its unit over there. That is related to intensity. And when we go more in detail, then the word which I said that these quantities can be taken for very largest and for very smallest over there, then I will have to use prefixes. Prefixes is basically the words or letters added before SI units is called prefixes. For example, we can take millimeter, we can take kilometer, we can take megajoules. All of these are the prefixes. Millimeter is for smallest quantities and megajoules is for largest quantities over there. For example, I am adding here from 10 raised to power 12. The largest value means 1 with 12 zeros over there. Then it will be, don't know, tera. 10 raised to power 9 will be giga. 10 raised to power 6 will be mega. 10 raised to power 3 will be kilo. And 10 raised to power 2 will be hecto. And 10 raised to power 1 can be deca. On the other end, 10 raised to power minus 1 will be deci. 10 raised to power minus 2 will be centi. 10 raised to power minus 3 will be milli. 10 raised to power minus 6 will be micro. 10 raised to power minus 9 will be nano. And 10 raised to power minus 12 will be pico. For tera, we use capital letter T. For giga, we use capital letter G. Mega, capital letter M. Kilo, capital letter K. Hecto, small h. And deca, small capital D. And for deci, we use small d, centi, small c, milli, small m, micro, like a mu shape over there, nano, small n, and pico as small p over there. These are the prefixes which are used to represent the very smallest is being taken with the help of negative power, like the size of virus, size of nucleus of an atom over there. And for the very largest, which we can say we can take for a distance of Earth to Sun or Earth to Moon over there, size of Earth over there, these prefixes can be used for showing the distance differences over there. After that, after the prefixes, we will have to move about significant figures. Significant figures. Significant figures, we can say all accurately known digits. Accurately known digits and first doubtful digit. First doubtful digit is called significant figure. For example, I am taking here a measurement of a table which is giving me the length 14.27, which is giving me 14.22, which is giving me 14.23, which is giving me 14.27 again. You can observe here 14.2, 14.2, 14.2, 14.2 are all available which are accurately known, but the doubtful is 7, doubtful is 2, doubtful is 3, doubtful is 7. And if it is having 0, it is having 3, 3, it is having 2, 5, it is having 7, 4. I will ignore 4, 5, 3, 0 like that. I will write here 14.27 or like that. All these will be 4 significant figures measurement over there. So all accurately known digits and first doubtful digit is going towards significant figures over there. And if we are talking about significant figures which can be significant and which can't be significant over there, for example, it is written 0.0047. On the other hand, it is written 0.000407. It is written 0.00470. If you observe here, the zeros on the left side will not be significant. 0 on the left side will not be significant, but 0 between two non-zero digits is significant. Zeros to the left and zeros to the right are not significant over there. So we can say zeros on the left side, 0 on the right is non-significant. 0 between on the left only, 0 on the left only is non-significant. For significant, it should be placed between two non-zero digits over there. Is it clear? Okay. After significant figures, we will have to take little bit the basic formulas related to mathematics over there, which are related to the area of a square, area of square like that. If we want to take area of square on the graph over there, then we are provided by some rectangular graphs over there, and these these squares are being shaded in the form of area. And if the length of one square you have taken according to the x-axis and y-axis over there, then the length of each square will be giving by totaling the number of squares. Then we present that length multiply length will give you the area of the square over there. In case of right angled triangle or normal triangle, for example, the triangle is given in this form or the triangle is given in this form, then you know the area of right angled triangle, yeah, area of triangle will equal to 1 by 2 base multiply height. In this case, base and height are given. In this case, this whole is base. And you will have to find first this height. If you know this, then you can implement this formula for the calculation of total area over there. All right, this can be taken. And when this is related to area, which is basically 2D plan, 2D plan over there. When I go for volume to be taken into account, it means I go for 3D plan over there. In that case, I will say volume of some cube or cuboid can be taken into account. Volume of cube or cuboid can be taken into account. Then in this case, volume of cube will have all of its dimensions equal in length, and all these dimensions are being taken in this format. Then we can say this cube is having its volume length multiply length can be taken as L cube. But in case of cuboid, we can say the rectangle is there. Another rectangle is being drawn in this format, in which we can say length, width, and height are of different. Then we can say length multiply width multiply height can be taken for the volume of cuboid over there. And another regular shape which we have to take, that is the cylinder, volume of cylinder. For example, I have this cylinder over there, in which it is having some radius over there, it is having some height over there. I say from here to here it is a radius, because it is the circular cylinder over there, and it is its height over there. Then I can say, if I know the base area multiply height, then I can use the formula pi r square h will be the volume of cylinder over there. After that, when we are done with the volume section over there, we will have to take the time. Time is measured in seconds over there, and will also be taken like to measure the speed of sound, like you want to check over there. We can also use simple pendulum to measure the time period, and time can be taken into account over there. But here I will have to go for the types of errors over there. Um, Types of errors, like when some measurement is being taken with the help of some student over there, the first error which can be happen is called personal error. Like the student doesn't know how to use the apparatus, he does not know, he don't have a knowledge related to that instrument to use over there. That is called personal error. Second one can be a systematic error. Systematic error, the error which happens due to the faulty apparatus over there, like the vernier caliper which he is using over there is not properly designed, and it has some zero error, and then zero correction with positive, like some measurement is taken and some fixed amount should be added or subtracted to get some correct value. That error is called systematic error. And at the end, the third one is called random error over there. Random error is that error, for example, you repeat to measure the time duration of some event, like you are turning on the fan, and fan is taking to get its full speed with the help of use of stopwatch. Every time you take a little bit difference in the 1 second or 0.5 second or 0.2 second, like that, then that error which is happening due to repetition of experiment is called random error, and it can be minimized by using average. By using the mean and average over there, we can remove the random error. Systematic error can be removed by comparing it with the a normal, not faulty apparatus over there. Then that constant value should always be added or subtracted to get the correct value over there. And personal error can be removed by getting the knowledge about the correct measurement over there. After that, in physical quantities or the quantities over there, I will say that when we say there are physical quantities, then I will say there are basically two more types of quantities. The seven which I have given above, those are called base quantities over there. Quantities, that those were seven base quantities which we have noted down above, that were length, and then I can say seven base quantities over there: length, mass, time, temperature, amount of substance, electric current, and luminous intensity over there. 4, 5, 6, 7. So these are the base quantities, but the other one in quantities of physical quantities we will have to take, those are called derived quantities, means which are extracted on the basis of base quantities are called derived quantities, which are being taken as like for speed, it is meter per second unit over there. It is velocity, can also be having the same unit like meter per second, scalar or vector form over there. And I can also take acceleration, having the unit over there meter per second square. There can be power, having the unit watt over there. There can be work. All of these which I am writing right now are the derived quantities in the form of joule, and there can be force which can have the unit as Newton over there. When I am saying that there are scalar and vector quantities over there, then we should take scalars and vectors. What are the scalars quantities and what are the vector quantities? Scalar quantities. All the quantities which have magnitude and unit only are called scalar quantities there. All quantities which have magnitude and unit only. Magnitude and unit. So direction is not involved in scalar quantities over there. Let's suppose it can be distance, it can be speed, it can be mass, it can be energy, it can be density, it can be volume, it can be work, it can be power. All these are the examples of scalar quantities over there. And I again tell you that it has only magnitude and unit, like 6 meter, not mentioned in any which direction over there. 50 meter per second, not mentioned in which direction over there. 50 kg, not right, not left over there. 30 joules, no direction mentioned. Density of water like 1000 kg meter per cube, no direction required. Volume of this room is 30 meter cube. 30 meter, 3 meter per cube over there, 3 meter cube over there. Work, power, all these are. I also say that there is pressure is a scalar quantity over there. On the other end, there is vector quantity. Vector quantity. Vector quantities, all those quantities which have magnitude, direction, and unit are called vector quantities. For example, for distance, I will say there is displacement. Displacement. There can be speed, can be velocity. There can be acceleration. There can be force. There can be force right, left. It can be having the direction right, upward, downward, forward, backward, like that. Can be taken for force. There is acceleration, force. After that, moment and momentum over there. For representing a vector quantity over there, we use a head to tail rule. For example, I am having two vectors here. This is my vector A, or this is my force vector F1, and this is my force F2 as a vector quantity. And I say to you, just add both of these quantities. But before going towards that, I will say the length of this force will show the magnitude, and this arrowhead will show the direction. And force is having the unit Newton over there can be taken into account. Vector is having magnitude, vector is having direction, vector is having unit over there. So whenever we are adding both of these vectors, this is F1, F2, then we join both of these vectors like this. Then we join the head of last vector to the tail of first vector to get the resultant vector over there. And the the rule in which we join all vectors via head of first one to the tail of next one, tail of next one, and so on, and so on, and we join the head of head of last vector to the tail of first vector over there, then this is called the rule which I started in the start. I said the rule in which we join all the vectors. Like right now it is one vector and two vector are given. I joined the head of this vector to the tail of next vector. Again, I can add the next more vector, the tail with it and head for the free one, and like this one. And in the last, the head of last vector to join the tail of first vector to get the resultant vector over there. This is called head to tail rule. Head to tail rule, which is used for getting the resultant vector quantity over there. And we can also take for here the more in details, which where we can take for that magnitude of vector. You know about the Pythagoras theorem, magnitude of vector, magnitude of vector. For example, you are having a vector like this and this in 2D plane. This is your x-axis and this is your y-axis there, and you want to get its magnitude over there, and this is your force F in the form of vector. Then you can take Fx and Fy over there and applying a Pythagoras theorem over there. Then I will say magnitude of force F will be given as Fx square plus Fy square. As you have studied in mathematics, like base square plus perpendicular square is equal to hypotenuse square over there. And if we go for direction, then I am applying the tan theta over there. Tan theta is equal to perpendicular Fy over base Fx. Then theta, or the direction of vector, can be calculated by tan inverse Fy over Fx. One thing more I should tell here, that these formulas will be used in A levels, but according to the explanation of vectors, I have added it all. This is related to your physical quantities according to O level syllabus over there.